So we already know what degrees are. We know, actually, how much is half a circle in degrees? Raise your hand. Ari. What? 180. Do you want gobstoppers? I don't have anything else. How many degrees then are in a full circle? 360. Yes?
Yes.
All yellow?
No.
Oh, orange and yellow. Okay, so this is what I want to say. Those are the important things that we're going to look at. I think one time I talked about what radians are. It's kind of weird. It's not necessary to know this. I will talk about it, and I'll show it in this. But the important thing is that 180 degrees is going to be the same thing as 3.14159.159.265.4 radians. Pi.
Why do we call it pi?
Radians.
Oh, it's not written.
It's a Greek letter. So they just...
It says radians. Oh.
Radians. It's my A is connected to my N. There. Radians. Rads for short. That's what it says on the calculator. If you're not in degree mode, you're in radian mode. But 80 degrees is pi radians, and 360 degrees is, well, 2 times 180 is 360, so 2 times pi will be the full circle. Radians are just another way to measure angles. But this is the important information here. Also, do we remember the formula for area of a circle? If you don't, it's written somewhere in this room. Say it again.
Pi r squared.
Pi r squared. Do you want gobstoppers?
I like gobstoppers.
Emilia, watch out. I couldn't throw it far enough. Pi r squared. That's the area for an entire circle. So I'll say area of circle. And that's the r is the radius there. So really, what are radians? What are radians? You don't have to write this down. I just want to show you. It's not super necessary, but it's good to understand what we're talking about. So 1 radian is the same thing as 1 radius. They're like similar words. Radian comes from radius, the word radius. So if this is 1 radius, 1 radian will be an angle measure, and that angle measure, 1 radian, will be however much I have to travel here so that this distance, this radius distance, is the same as this arc length. And then that angle would be 1 radian. So you measure it like, okay, 1/2 radians would be just however much you have to go out so that half of a radius fits on this arc length. 2 radians would be something like that, because you take this distance, whatever it is, maybe it's 5, and then travel 5 on the arc, and then another 5 on the arc. That would be 2 radians. It's just a measure of how far or how big the angle has to be so that that number of radii fit on the arc. That's really what a radian is, but it's not super important for us to be able to solve these problems. I think until you get to trig, you probably will be more comfortable using degrees rather than radians, but we're going to use both. So this was the important information, and that area of a circle is pi r squared. So right now we're going to focus on converting. So to convert, continue, what? Convert. This is converting between radians and degrees. So I guess I'll say radians and degrees. This is actually, you're going to use the same fraction but flipped over depending on which direction you want to convert to. So if you start with degrees and you want to go to radians, you'll use some fraction that I'm going to tell you, some proportion, or some ratio rather. And if you're going from radians to degrees the other way, then you'll just flip that ratio over. So I'm going to say to go from radians to degrees or degrees to radians, use either 100, and it's going to be this, just 180 degrees over pi radians, or, and then flip it over, pi radians over 180 degrees. So those are the ratios that we're going to end up using to convert between whatever we have. This is the easy part of this lesson. So convert to degrees, and we're given 17 pi over 18 radians. Some people might be thinking, what the heck is that? What? 17 pi over 18 radians? I could figure out a decimal for that, but it's much cleaner to just write this fraction. So I'm going to show the decimal, but I'm not going to actually use it. 17 times pi, that's this button down here, equals, so that's 53 something, and then divided by 18. So that means whatever angle on a circle, again, don't write this, that means if this is 1 radius, that length, I need 1 radius, 2 radii, here's maybe 3 radii, maybe I need a little bit less. This would be 2.967 blah 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 radii. That's what that means. It's not super important that you understand that completely. All we're trying to do here is convert this to degrees. So the hint here, or the note that you should remember, if I could find my red pen, I found it, is to choose ratio, that's either this or this, so that things cancel. So choose your ratio so that things cancel. And I'll show you what I mean by that in a minute. Sorry. Choose the ratio so that things cancel. So if I write down my radians again, 17 pi over 18. The radians, I'm thinking of it as the radians in the top. The radians are in the top. So in order for the radians to cancel, I'm going to choose the ratio that has radians in the bottom so that they cancel out. And that will be this one. And I'm just going to multiply. 180 degrees divided by pi radians. And that should give me something. So the radians will cancel. The pi's will cancel. And then I just multiply straight across the top and straight across the bottom. So 17 times 180. You could reduce this and not in the calculator. So the top would be 3060. Divide 18. That's 170 degrees. Now notice what we were saying here. All the way across would be 180. So a little bit less would be 170. Not perfect, but it was just a guess here. So 2.967 radii is the same as 170 degrees. So let's see part B. And what do we got? What do we got? So still convert to degrees. 23 pi over 18. radians. Once again, I'm looking at this ratio because I want it to cancel out with this radians. So 180 degrees divided by pi radians. Radians cancel, same with the pi. Very nice. And then you can just do the rest in your calculator or simplify it in your head. This would be 18 divided by 18 divided by 18, you get 230, yeah. So 23 times 180, and then divided by 18, 230 degrees. So far, hopefully it's easy. The next part will also be easy, but let's see what we can do. So convert to radians, 35 degrees. I think maybe it's helpful if you scribble out the degree little circle and write in degree. Then you know, hopefully, that degree is on the top. So you would choose this ratio because degree is on the bottom, and they would cancel. So you're just multiplying by pi radians over 180 degrees. The degrees will cancel, leaving you with radians. So we have 35 pi over 180, no more degrees because they canceled. And then you just reduce, I think we can reduce by 5. And that would be 7 pi over, what's 180 divided by 5? 36. And I can't reduce anymore. That's rad, dude. That was dumb. So the question was like, if we're multiplying, why does degree and degree cancel? This is like over 1, and when you multiply straight across the top. So this degree and this radians will be on top. This degree will be on the bottom. So we have degree on the top and degree on the bottom. Then it's like we're dividing. Like if you had something like, let's see, if you had something like this, 2/3 times 5 halves, multiply straight across the top, and you get 2 times 5 and 3 times 2. You can cancel those out because one's on the top, one's on the bottom. You get 5 over 3. The long way to do it would be 2 times 5, 3 times 2. That would give you 10 and 6, and then reduce by 2. And you get 5 over 3. But here, the units, one's on top, one's on bottom, so they cancel. So try this. Still converting to radians, we'll have 75 degrees. Convert that to radians. So on this one, again, we're using this ratio because we want the degrees to cancel out. So I'd be multiplying, it's like over 1, multiplying by pi radians over 180 degrees. And then, so that degree cancels out with that. And we have, because that would be DEG, we cancel those out. 75 pi divided by 180. And my initial reaction was, oh, I can divide both by 5. But then I get 15 pi over 36. And I can continue by dividing by 3. So that would be 5 pi over 12. I can't reduce anymore. And those are in radians. So that's my answer there. 5 pi over 12 radians.